So I'm showing you that temperature is not like other units because 0 degrees Fahrenheit is not equal to 0 degrees Celsius. And neither of them is zero the stuff they're measuring. So, it's like 0 feet and 0 inches are the same distance. So no feet is no inches. If you looked at it as a slope, you'd say, any unit on one axis, any unit on the other, they both hit 0 at the same spot. No distance is no distance. Then you'd say, okay, well, no liters is no gallons, right? So any volume changes, you'd see the same thing. You'd have none is none. And that's completely look similar, maybe a different slope, right? But similar idea. Now, but, and that's a big but, that 0 degrees Celsius is equal to 32 degrees Fahrenheit. And so it looks like this. There's a slope like there would be otherwise, but there's also an intercept. And so there's an offset by 32 when you hit 0 Celsius. You actually still have 32 degrees Fahrenheit. And interestingly, neither is a lack of the thing it's measuring, which is we're going to call heat. Not just to make things simple, it's not really heat, but we're going to call it heat. And the slopes might look like something down here. I'll show you in just a moment. So if you're measuring heat, you'd have Fahrenheit has one slope, but not 0. Celsius has another slope, still not 0, and they don't meet. But the Kelvin temperature does have lack of that stuff. Well, they just didn't know. Like when they started measuring temperature before they knew what they were measuring. But 0 degrees Kelvin is no heat. Same scale as same slope. I tried to represent the same slope as Celsius, but it goes through 0. So, how to convert between Fahrenheit and Celsius? Well, you have to either subtract, then add, then subtract. It's not ideal. It's not fun. It takes a little practice, but here's what you do. You must recognize that degrees Fahrenheit is equal to 1.8 times degrees Celsius plus 32. And degrees Celsius, conversely, is degrees Fahrenheit minus 32 divided by 1.8. You got it. So what do you do? So practically speaking, what do you do? If you have like an example, here's what you do. So I mentioned here that once you multiply, then add the other one, you subtract, then divide. And the order of operations is important. Here's an example. So if you have 107 degrees Fahrenheit, how do you convert that to Celsius? Right? And I'm going to go a little slow here so that you can sort of absorb some of this and change colors a lot so that you can track easier. So take the 107, we're going to plug it into that equation up there. Therefore, 107 minus 32 divided by 1.8 is going to be equal to whatever that same temperature is in Celsius. And here's the operations. 107 minus 32 is equal to, carry the 5, subtract by 1, take a remainder, take the cube root, it's just 75, which I'm sure you know. And 75, then that result minus, or divided by 1.8 is our answer. So we'll just take an extra step and we'll do that. Changing the color 75 divided by 1.8 is equal to degrees Celsius, which in this case is 41.66667. 6666667. It's an irrational number. But what do we report? Well, we report however many significant figures allow us to. In this case, we don't count what we subtract or what we divide by because they're part of the definition of the conversion. They're conversion factors. We don't count the significant figures of our conversion factor. So we get 2. Then we identify 2 significant figures, and our answer in this case must contain 2 significant figures. The 1.8 doesn't count. All right, so because let's see, it's a definition. It's defined. Definitions have infinite precision. They don't count towards our error analysis. With this answer, we'll just identify that we can report 2 digits. We get 2. How many? How what it gets to. And we will basically we're done now. This is just me taking more time writing this out. Sorry, I'm narrating this, a few hours after I originally recorded, realizing that my sound wasn't being recorded. And that's the answer, 42. So anyway, that's how you do it, and it's just, I'm not going to bore you by explaining it the other direction. It's just the same thing backwards, just a little concept note for you in temperature changes in case you're having a little trouble. And, like always, I hope that helps, and I'm Rick Morgan, and I'll see you next time. Take care.